No, today we are discussing KNN, K nearest neighbors. Yeah. So today we are discussing the algorithm called K nearest neighbors. It's a both classification and regression algorithm. So we'll be discussing the algorithm called K nearest neighbors. Okay. So we have discussed a couple of algorithms in Python only, but we will be discussing them again in R when we are doing it R. Because R, I think, will start next week onwards, because R is a statistical software. Python does not use statistical output. So the same algorithms which we have discussed in Python will be discussed from the beginning in R. Okay. So R is where the outputs will be completely different, because there will be statistical outputs. Whereas in Python, we don't get any statistical output. We don't get any p-values. We just get the basic required metrics only. So all the algorithms which we have covered till now will be again discussed in our right from basic, because there it's a completely different. When you look at a statistical output, it's a different thing. Okay. So today we will be going on with the K nearest neighbors. KNN algorithm. K nearest neighbors. Also called as KNN. KNN algorithm is used for both regression and classification, but predominantly it is used for classification only. Predominantly used for classification, because its performance on regression data is not as good compared to the tree-based models. So it is a predominantly used for classification. It can be also used for regression, but the performance of the model compared to other models like random forest, gradient boosting, or neural networks, or any other models, it will be less. Okay, so K nearest neighbors, K is a very what you call, it's a very easy to implement algorithm. It is a very easy to implement algorithm. And the algorithm uses distance method like Euclidean, Manhattan, Hamming, Canberra, etc. for calculating the distance between the predicted value and nearest neighbors. Predicted value and nearest neighbor. It uses a distance-based algorithm. Till now, we have not discussed any distance-based algorithm. This is the first distance-based algorithm. So we have different sets of algorithms, right? Regression, multiple linear regression, and binary logistic regression is based on matrix multiplication and matrix calculations. Tree-based algorithms, decision tree, random forest, gradient boosting, they are all what you call probability and based on probability calculations, Gini and entropy calculations. Even neighbors is a pure Bayesian probability-based calculation, probability-based calculations. In KNN, we use distance. The distance is the core metric in KNN algorithm. Euclidean distance. We all know Euclidean distance, right? Y2 x2 minus x1 whole square root of x2 minus x1 whole square plus y2 minus y1 whole square. Euclidean distance calculates the distance between 2 points on a plane, geometrical plane, Euclidean distance. So there are different variants of distance methods are there. I will discuss their formulas now. But basically, KNN is a distance-based algorithm. KNN is considered, is also called as a lazy algorithm. KNN is also called as lazy algorithm, as it does not start calculating until a value for prediction is given. A value for prediction is given, it will not calculate. What it will do, it simply stores the data and starts calculating once predicted value given. So till the predicted value is given, it will simply store the data. It will simply store the data. It will not do anything until a predicted value, a value for prediction is given to it. Till that time, it will not do anything. So it's why it's called lazy algorithm. Next, KNN uses majority voting method for deciding the final class of the prediction and in classification method, and uses average method when predicting value in regression. So when you are using this algorithm as classification algorithm, the final prediction is based on majority voting. The majority voting is used. I'll explain what is this majority voting. While calculating, we will understand. And average method. Average of the nearest neighbors will be taken in case of regression. One other thing is the value of K. The value of K must be an integer. Integer means a discrete value, 1, 2, 3, 4, right? Value of K must be an integer, and initially a random value will be given, and based on the performance, the K value will be adjusted. So K in K nearest neighbors is a value. It has to be a value, say K is equal to 5, K is equal to 10, K is equal to 20. You can give any integer value. There is no fixed formula for deciding the K value. There is no fixed formula to decide the K value. What we generally do is, we use different values for K, build different models, and then finalize the model that has the best performance. When I say performance, accuracy in case of classification, R-square in case of regression. The performance matrices in classification, we use accuracy. In case of regression, we use R-square. Based on that, we will decide which is the best fit model. So this K method, generally what we do is, we use grid search algorithms. These are now available. Grid search algorithms will use different combination of values. and identify the best fit model. So, grid search algorithms are widely used in places where we have this K nearest neighbors, K means clustering, hierarchical clustering. Wherever you have to give a value for K, you have to use grid search. Even we can use in random forest and gradient boosting. We have to give number of trees, right? We have to give number of trees in gradient boosting and random forest. How we will do? By default, it gives you 100 trees. If you want to go beyond that, how will you do? We randomly pick a number and give, and then we see how the variance is there, and then we will come up with the final value. So similarly, principal components analysis, PCA algorithm also we have to give how many components are there. So whenever there is there is a need for identifying a specific value, these grid search algorithms will help us. You give them a combination of values. It will try all the combination of values and it will give you the best combination of the value as a final output. So that is one way of, that is one of the best method to find the best value for K. Okay. Next thing is, for all distance-based algorithms, scaling must be done. Remember scaling? Standard scaler. Predominantly we use standard scaler. What is standard scaler? Z-score. Standard scaler or Z-score is equal to X minus mean divided by standard deviation. We convert the values into Z-scores. Now, this will reduce the size of the value. Why scaling is done? To reduce the size of the values. Size of the values means, suppose you have a variable in lakhs. If you scale it, it is easy for computing purposes. If you run a standard scaler on lakhs value, it will scale the value between -3 to +3. Then it will be easy for us to what you call calculate the computational processes will be easy. Okay, so that is the reason why scaling is required, or you can also use the other one, which is min-max scaler. Min-max scaler, also called as, what is the formula for min-max scaler? X minus X min divided by X max minus X min. Min-max scaler will scale all the values between 0 and 1. Only positive values you will get. Whatever may be the value range, it will be scaled into the range of 0 to 1. No negative values, only positive values. Suppose you are dealing with large scale data, you don't want any negative values, already computations are there. So it's better to scale using min-max scaling. So scaling is a way, the distance algorithms, before you run a distance algorithm, be it KNN, be it K-means, you have to scale the data. Either use standard scaler, the most preferred scaler, or min-max scaler, or normalization has to be done. So now, if you look at the distance methods, there are many distance methods, but the popular distance methods so we have methods Okay. Where are the formulas? Hmm. So we have, these are the predominantly used distance methods. So Canberra, Minkowski, Chebyshev, Euclidean, Manhattan. So these are the mostly used ones. These are the most prominent ones which are used, the distance methods. The most is Euclidean, because we are all familiar with Euclidean. We use Euclidean. Square root of sigma xi minus yi whole square. Distance between 2 points. Manhattan is absolute. Xi minus yi. Sigma. Max of xi minus y is Chebyshev. To the power of r. Exponential to the power of r by 1 by r is Minkowski. And Canberra is xi minus yi absolute of xi yi divided by xi plus yi. And if you are using text data, we use Hamming distance. Text mining also we will do. We use distance methods in text also, natural language processing. There, the predominantly used method is Hamming. Hamming is a very predominantly used method in what we call text. So let us say we have an example here. So we have, binary aspects of text data. These are two vectors, two text data vectors converted into numerical matrix. Now we convert the data of text into matrices. We call them as document term matrix or term document matrix. We convert them into matrices. If it is 1 and 1, it will be 0. If it is not matching, then you sum of that will be your Hamming distance. So what we do is we take the words and we'll convert those words into a matrix of numbers. How we do it is, suppose you have a, let us say tweets. You all know tweets, right? So we have 10 tweets. We break the 10 tweets, we clean them up, we get the core sentence of the tweet. We break those sentences into words. Now, tweet 1, what words? On the column. Words of the tweet 1 on the column. And then if the tweet 1, the words are there, you will get 1 and 0. If it is there, 1. If it is not there, 0. Similarly, tweet 2, it will compare with those words. If it is there, 1. If it is not there, 0. So they will create a matrices using this type of thing. So people use common words, right? In tweets, you will see common words. If it is a topic is common, like say COVID, the tweet will have common words like fever, pandemic, disease, right? So tweets will have common words like what you call or non-common words. Specific words will be there, like geographic name, city names, right? Non-specific, non-common names will be there. So you have a list of common and non-common words. Using that, it will calculate Hamming distance. Hamming distance is predominantly used in only natural language processing. When I'm discussing NLP, I will discuss in detail what this NLP will calculate it also. Okay. So these are the predominantly used distance measures in distance algorithms, be it k-means, be it KNN, whatever is the distance-based algorithm. These are the common distance methods. Now, we will also have to understand that KNN was one of the oldest algorithms. It was one of the old algorithms compared to the random forest and gradient boosting, which emerged later. KNN is a very, very old algorithm. Initially, a lot of work was done, a lot of measures, distance measures, even today, a lot of distance measures are being developed within this distance-based algorithms, and new algorithms are being created. Okay, so this is the theoretical background of KNN algorithm. Okay, now let us start the calculation. We have a classification sheet here. If you go to the classification sheet, the data sheet, all of you. Now here, if you look at the data here, we have, let us say, two independent variables, x1, x2, and one dependent variable, y. Right. So the dependent variable, what is the dependent variable here? Or the variable that is being predicted is t-shirt size. We are predicting the t-shirt size using the two independent variables, height and weight. The independent variables that are used here are height and weight. Based on the height and weight of the person, we are trying to find out the t-shirt size. We want to predict it, we want to build a model that will predict the t-shirt size. We want to build a model that will predict the t-shirt size. Right? And we have some historical data. This is our historical data we have of already data is available. Now, what we have to do is find the t-shirt size if the person's height is 158 centimeters and if the person's weight is 70 kgs. What should be the t-shirt size that you recommend to that person? What is the t-shirt size recommended to a person whose height is 158 centimeters, whose weight is 70 kilograms? Height is in centimeters, weight in kilograms. So now what we have to do? We have to use the KNN algorithm to find out which t-shirt size the algorithm will suggest to the person. Like I told you, we need to scale the data. Like I told you, first we need to scale the data. That is the first thing which we have to do in KNN algorithm. We have to scale the data. Now, height underscore scale, weight underscore scale. So we have to scale the data. Now for scaling, what we need? We need average, we need standard deviation. We need average, we need standard deviation. For scaling the data, we need average and standard deviation. So we let us calculate. Is equal to average, open bracket, then select the values, is equal to average, and then select the values. You got the average of 164. I will drag the formula to the right side. For weight, it is 62.33. The average of weight is 62.33. The average of height is 164. Similarly, standard deviation is equal to STD EV. Select the values. STD EV, select the values. Standard deviation is 4.32 and standard deviation of weight is 2.36. You can reduce the decimal to 2. For convenience sake, we'll reduce the decimal to. Okay. Now, what is the formula for you? We will use Euclidean distance. We will use Euclidean distance. But, sorry, not Euclidean. We will use Euclidean distance. Okay, that is there. We will use standard scalar. For scaling, we will use standard scalar. For scaling, we use standard scalar. For calculating distance, we will use Euclidean distance. Now, what is the formula of standard scalar? Is equal to open bracket x minus mean. Now, mean is common for all, right? If you are going to drag the formula, you have to fix it by pressing F4, absolute cell referencing. You have to fix the cell by pressing F4 or Fn plus F4. Close bracket divided by standard deviation. Standard deviation is also common for all. So fix it by pressing Fn plus F4 or F4, absolute cell referencing. Absolute cell referencing means that two cells should not move. Even if you drag the formula, typically if you drag the formula, Excel shifts to the next formula, right? We don't want it to happen. So we are doing the dollar signs. We call it as absolute cell referencing. So we got the value. Now you can simply double click. It will calculate for all the values. For any value, the mean and the standard deviation will not change. If you don't fix the formulas, the cells will shift downwards and you will get 0 as the answer. So you have to do absolute cell referencing so that these cells have to shift. X has to change, but mean and standard deviation should not change. That's why you're fixing only the two cells, which are the mean cell and the standard deviation cell. So A22 and A21 are our mean and standard deviation cells, which are fixed. The A1, these A2 cells should change. They have to go one by one downward. You should not fix them. Similarly, for weight also is equal to open bracket weight x minus mean, fix it by pressing Fn plus F4 or F4 divided by standard deviation, again Fn plus F4, Fn plus F4 to get, and then double click. It will calculate for all. The cells will change, but sorry, the X will change, but mean and standard deviation remains constant. Fn plus F4. Most of the laptops, you have an Fn button on the left side. Fn plus F4. F4, 4. Function F4 or you can directly in keyboards, it is direct F4 directly. Now we will calculate the distance. Euclidean distance. We will calculate the Euclidean distance. Before that, we have to scale these two also, because these also have to be scaled, right? These values also have to be scaled. That means is equal to 158 minus 164 divided by 4.33. This also has to be scaled, is equal to 70 minus 62.33 divided by 2.63. The predicted values also have to be scaled. They all should be in same mathematical unit. Okay, we are scaling both the values. These are the scaled values of this. Okay. Now the distance SQRT, open two brackets, x2 minus x1 to the power of 2 plus open bracket y2 minus y1 to the power of 2. Here also the x2 and y2 has to be fixed because they're common, right? These two cells have to be fixed, right? G and H, because you are calculating distance from this point. This is the common point from which you are calculating distance to all the other observations. So is equal to square root of open two brackets G7 minus D2 whole square plus H7 minus E2 whole square and close bracket. You got distance of 3.83. Now if you double click, you will see the distance will be, these two cells will be constant and these cells will be automatically changing. Okay, right? Just put insert a column, otherwise. Okay, now what we will do, you select the distance, go to home tab, sort and filter, smallest to largest, expand, sort. Smallest to largest, expand, sort. So assume K is equal to 5. If I assume K is equal to 5, that means 1, 2, 3, 4, 5. 5 smallest distances. 5 smallest distances. Majority voting. 4 to 1. 4 largest to 1 n. So majority voting says the t-shirt size, if you assume K is L. If you assume K is equal to 5, it is L. If you assume K is equal to 3, the top 3 distances L, it will be L only. So that's what, there is no fixed formula. We have to come up with the best possible K using grid search algorithm. When I'm implementing it on Python, I will show you how to get the value of K. See, generally, it depends on the data size. By default, is K is equal to 5. But it all depends on the data size. So, square root. Square root of x2 minus x1 whole square plus y2 minus y1 whole square. X2 and y2 are these two values. Hey, got the formula? See. Marker is not there. Marker. Stay in the So for the first observation, it is square root of minus 1.387 minus 28 is how much? Height, right? Minus 0.924, right? Whole square plus 2.90 minus 0.3. Here's the problem. So this we have to fix. These values are common, right? This has to be Fn plus F4. Fn plus F4, function plus F4, right? So those two values have to be fixed.
For example, if you value
No, you can change. So what we want to do is we have to automate this too also. Is equal to max of max of character. How will get the character max? Most frequent string, right? Excel. Sometimes I forget these formulas. Most frequent string in Excel. I think it is saying mode. Okay. Most frequent occurring text in Excel. It is index match, huh? Index only, index mode match. Index mode match. Control plus Alt plus enter. Shift plus enter. Okay. is equal to is equal to index, correct? Open bracket, index of 1, 2, 3, 4, 5. Okay, comma, mode of match of this, comma, again, comma, 0, 1, 2, 2. Control plus shift plus enter. Yeah, got it. Okay. So I have used this formula, index match formula, array formula. So we got L. Now let us say I will reduce the height to 140, weight to 45. Now we have to sort the distance also, right? Smallest to largest, sort. So once you sort the distance, you will get the t-shirt size as M. I put an automation here. By taking the k is equal to 5 cells, it will automatically get it. Right? Index match function. So if you want automation, you can do that. So once you have the model, all you have to do is sort. You just sort the data distance, then you will get the t-shirt size. You can also write a macro for sorting the distance also. But again, why to do all those things? This is a small calculation problem, right? So this is how it will work. So if you say 170 and weight is 80, and then you sort the distance, editing smallest to largest, sort, you get the L. Right? Got the process? Scaling and then calculating the Euclidean distance, and then we will get the thing. Fine. This is how it will work. Now try doing it for regression. Regression, you have to predict the house price index, scale the data, just scale age and loan. Just try do it for regression problem. Same age underscore scale and loan underscore scale. First scale. Scale for regression data, scale the data. For scaling, you have to calculate the mean and standard deviation.
Equal to 5.
Index match function.
Range between, sir.
Which one?
5 values of range better.
Pattern. We are k is equal to 5 means we have to take whatever is happening in that first 5 cells, right?
You index to 4 index.
So, and control shift enter, not the direct enter. You have to use control plus shift plus enter. Array formula, na? Data array formula, you have to use control plus shift plus enter. Do not press enter directly. You have to press control plus shift plus enter. Use Control plus Shift plus Enter. Please do not press Enter directly.
In actually working in the others, the still but never there's